निर्माण हो अभिगम कल्याण हो छात्र नो हरदम उच्च अभ्यास नो शिक्षण धाम महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल महर्षि गुरुकुल.
Hello students, in this session we will be studying chapter 2, polynomials. We will be dealing with the introduction of exercise 2.1 and this chapter is from your NCERT textbook class 9 mathematics. The word polynomials is a very vast word to be explained. But before moving on to polynomials, let us see or let us explore some of the terms that will take us to that term, polynomials. Some important terms are to be kept in mind. The very first thing that we should have learned in our previous classes is algebraic expression. Algebra part that we have gone through in our previous classes 6, 7 and 8. Out of there a word was derived as algebraic expression. Algebraic expression. Algebra. X, Y, from when the algebra started, our teachers used to denote us with variables X, Y, Z, constant, 2, 4, constants, variables. What are constants and what are variables? This is all we have gone through in our previous classes. Then a combination of variables with constants. Combination of more than one variable with constants. Combination of variables with variables. Everything was termed as an algebraic expression. Variables. Variables means those are whose values keeps on changing. Say what we say X. It's a variable. Then what is the value of X? We don't know. We haven't assigned any value to X. X can take any value. Similarly, if we say 5, yes, 5 is a constant value. Why constant? Because the value is fixed. It cannot change. Means those whose value changes are termed as variables and those whose values are fixed are termed as constants. Moving to our topic, algebraic expression, combination of a variable with a variable, combination of a variable with a constant, combination of two different types of variables, combination of same types of variables. Let us see, we will be moving through various types of algebraic expressions and then we will notice how they are combined. The very first, we say X, okay, then we will be taking X plus 2, then we will be taking X plus X2, then we can take X plus X squared plus 1, then we can say X plus Y, then we can say X plus Y plus Z, then we say 5, a constant, then we can say 1 by X plus Y to the power half. So, we can write numerous algebraic expressions. Now, this is an algebraic expression. The variable used here is X. It's a single term. If you see, only one term, X. Here, there are two terms separated by a plus sign. One variable is used and it is a combination of a variable with a constant. We have seen three things here. A variable combined with a constant. It's a two-term algebraic expression and only one variable is used, that is X. So this is also an algebraic expression, combination of a variable with a constant. Then next, X plus X squared. Again, there are two terms. One is X, second is X squared. So X plus X squared. Two terms. How many variables are there? One. x only, though there are two different terms, but the variable is x. And this is also an algebraic expression in one variable with two terms. Next, x plus x square plus 1, three terms, x square, 1. Combination of a variable with a constant. These are the two variables and a constant, and only one variable is used. So this is also an algebraic expression in one variable with three terms and combination of both the variable and the constant. Next, x plus y, another algebraic expression. How many variables? Two. One is x, another is y. So there are two variables, x and y. Separated by a plus sign means there are two terms also. Combination of variables. Again we have noticed three things. Combination of variables, combination of two variables, and algebraic expression which have two terms also. The next, x plus y plus z, three variables, naturally very clear to us. X, y and z, combination of variables, variable x, variable y and variable z. So this is an algebraic expression with three terms and three variables. 5. Oh, 5 is a constant term. Previously when I was explaining, I told you 5 is a constant term. Can we say 5 as an algebraic expression? Yes, we can say 5 to be an algebraic expression because there is also a variable x whose power is 0. We know anything to the power 0 is 1. So when x to the power 0 is 1, there is a variable x. But we don't call this as a variable. We consider it to be a constant value. So 5 is a constant value. Next, 1 by x plus y to the power half. This is also an algebraic expression with two terms, two variables. Clear? Now, relating these our topic algebraic expression to polynomials. What we were talking about, in each algebraic expression we have seen two things. One was number of terms we had noticed, and second, number of variables used. Number of terms and number of variables. There is one more thing we have to notice, but not now. We'll be moving on to that. First, number of terms. Here, how many terms were there? 1, 2, 2, 3, 2, 3, 1 and 2. These were all algebraic expressions. But can we say that these all algebraic expressions are polynomials? Maybe, we are not sure. Polynomials, we are not sure till now. But we can say that all algebraic expressions are polynomials, keeping in mind that the power of the variable should always be a whole number. The power of the variable should always be a whole number. Whole number means 0, 1, 2, 3, 4. These are our whole numbers. The variables that are used, the power of the variables should be a whole number. It should not be a negative number. It should not be a fraction. It should not be a decimal number, but simply it should be a whole number. That means the power of the variable can take the values 0, 1, 2, 3 and 4. Power. Here x we have. What is the power? Power means this. The power is 1. So this is a whole number. So we can consider this algebraic expression to be polynomial. Here also the power is 1. This is also a polynomial. Let us write the short form for polynomial. Here the power of x is 1, the power of x is 2, 2 and 1 and 2 both are whole numbers. So this is also polynomial. Here also power 1, 2 and this is also polynomial. This is a polynomial in two variables. The power of both the variables are 1 and both are whole numbers. So this can also be considered as a polynomial. Here we have three variables and all the three variables have power 1 and 1 is a whole number. So this is also a polynomial. Here, as I had told you in terms of constants, the power is always 0. So this is also a polynomial because 0 is also a whole number. Moving on to the last one, 1 by x. Y to the power half. This is half a fraction. That means fractions are not allowed in a polynomial. Moreover, this 1 by x can be written as x to the power minus 1 from the laws of exponent we have learned in our previous class. This is y to the power half. Both the values, one is a fraction, the other is a negative number. So this is not a polynomial. That means for an algebraic expression to be a polynomial, the power of the variable, if it is one variable, then also it's okay. If there are two variables, then also it's okay, or more than two variables. The power of each variable should be a whole number, then only an algebraic expression can be termed as a polynomial. If you want to write a definition, we can write any algebraic expression. Any algebraic expression with power of variables to be whole number, with power of variable or variables. If it is one variable, then it is single. If there are more than one variables or variables, with power of variables to be whole numbers, always whole numbers. Such a power is termed as a polynomial. That means any algebraic expression with power being a whole number for one variable or more than one variable can be termed as a polynomial. If the power of the variable is a fraction, if it's a negative number, if it's a decimal, then that algebraic expression will never be a polynomial. So since we are talking about polynomials, let us remove this example now and we will be dealing only with the polynomials. Now, previously I told we had two things to observe. One was number of terms, number of variables, and now let us take a third part also to discuss, and that is power of polynomial. In short, the exact term that should be used is degree of polynomial. This is the exact word a book uses. Many a time we say x to the power 0, many times we say x to the power degree is 0 or x degree is 0. So in short, here we will be using the word degree. Now for any of the polynomials, we have three things to be observed. One is how many variables are there. Second, how many number of terms are there. And third, what is the degree of the polynomial. Basing on these number of terms and degree of polynomials, we have categorized polynomials into different types of polynomials. But let us move on first with number of variables. Here number of variable is 1. Here number of variable is 1. Here number of variable is 1 because both the variables are same. Here also number of variables are 1. Number of variables 2. Number of variables 3. And number of variables 1. That's what we call it as a constant value. Now for number of terms. Number of terms here is 1. Here the number of terms are 2. Here the number of terms are 2. Here the number of terms are 3. 1, 2 and 3. Here the number of terms are 2. Number of terms 3 and number of terms 1. So when the number of term is 1, when the number of term is 1. We call that polynomial to be monomials. Monomials. If the number of terms is 1, it is a monomial. Out of these expressions, which one can be termed as a monomial? This one. This is my monomial. This is a monomial because number of terms is 1. Here also, this one can also be termed as a monomial because here also there is one term. Now if the number of terms are 2, if number of terms are 2, then such polynomials are called binomials. Such polynomials are called binomials where number of terms are 2. Here x plus 2, 1 term, 2 term. There are 2 terms, so this is my binomial. Then here also the number of terms are 2, so it is also a binomial. Then here the number of terms are 1, 2 and 3. So there might be some special name for number of terms to be 3. So when the number of terms is 3, this is called trinomials. The number of terms are 3, so this is also a trinomial. So when number of terms are more than 3, we haven't taken any of the examples with more than 3. Let us take one more. X cubed plus x squared plus x plus 1. Now the number of terms are 4. When the number of terms exceeds 3, we generally call them simply as polynomials. That doesn't mean that these are not polynomials. These are polynomials. But since the number of terms are small in size, we give them a particular name. These are also polynomials, but this can be called as monomials. With number of terms 2, binomials, a binomial is also a polynomial. A trinomial is also a polynomial. So monomial, binomial and trinomial are the simplest form of polynomials with number of terms 1, 2 and 3. But if the number of terms are more than 3, say 4, 5, 6, 7, we simply call them a polynomial. Then moving on to the next one, power of the polynomial. That simple word that we want to using is degree of the polynomial. Degree, here we have discussed power, we have checked when an algebraic expression was given to us whether it's a polynomial or not by the power, and that power will give you the degree of the polynomial. So degree of the polynomial is the highest value, highest power of the variable used in the polynomial. Highest power, let me tell you, remind you once again, if there are more than one term, then we will be seeing the highest power wherever the variable occurs. Let us see. Here, the degree of x is 1, the highest degree is 1. Here, it is a combination of a variable and a constant. So, variable's highest degree is 1. Here, it is a combination of a variable and a variable, 2 terms. And the highest degree of the variable, here the degree is 1, here the degree is 2. And the highest is 2. So, we consider that to be the degree of 2. If we move on further checking here also, degree 1, degree 2. So, highest degree is 2. So, degree of this whole polynomial is 2. Here there are 2 variables, a binomial, so this is a polynomial in 2 variables and each has an equal degree, that is 1. Moving on this way to this one, if you see the last one that we have taken, the highest degree here is 3. X has a degree 2, here x square, x1. The highest degree of x is, the highest power of x is 3. So we consider the degree of that polynomial to be 3 and so on. It can be of degree 4, it can be of degree 5, it can be of degree 6. So a polynomial can take a degree 1, 2, 3, 4, 5 and so on. But when it is of degree 1, again it has a special name. When it is of degree 2, it has again a special name. When it is of degree 3, it has again a special name. So what are the names? So let us see. If a polynomial has a highest degree 1, we call it as a linear polynomial. A polynomial with degree 1 is called as a linear polynomial. A polynomial with degree 2 is considered to be a quadratic polynomial, and a polynomial with degree 3 is called a cubic polynomial. Degree 1 linear, degree 2 quadratic, degree 3 cubic, and if it is of degree 4, then we don't have a special name, similarly as we have categorized in terms of number of terms. If it is more than 3, we consider it as a polynomial. Here also, if the degree is more than 3, we say it is a polynomial of degree 4. We call it as a polynomial of degree 5. We call it as a polynomial of degree 6. Now, let us revise what we have gone through once again. We have discussed regarding algebraic expressions. That algebraic expressions can be written in a combination form of a variable with a constant, variable with a variable. It can be of 1 term, 2 term, 3 terms, 4 terms, 5 terms. It can have more than one variables x, y, z. That means if it has x and y, it is x plus y. If we say it is a polynomial in 2 variables, polynomial in 3 variables. These are polynomials in 1 variable. This was a constant polynomial, and basing on number of terms, we have defined them as monomials, binomials, trinomials, and polynomials if it is more than 3 terms. And basing on the degree of the polynomial, say 1, we consider the degree of polynomial with 1 to be linear polynomial. With degree 2, it is quadratic polynomial. Degree 3, it is cubic polynomial. And if it is more than degree 3, we simply say it is a polynomial of degree 4 or degree 5 or degree 6. Keeping in mind, whenever you see an algebraic expression, first of all that you have to check is the power, the degree. The degree of each variable, if it is a whole number, then only that algebraic expression can be called as a polynomial, otherwise not. That means it can take the value, the power of that variable to be 0, 1, 2, 3, 4, all the whole numbers, then only it is a polynomial. If it is negative number, decimal number, fraction, then that algebraic expression cannot be termed as a polynomial. Now 2 more things that we will be moving on. One is coefficients. Let us move on with the word coefficients. Coefficient is always a constant value into variable. If it is given this way, then this constant value is called the coefficient of that variable. Suppose we are moving here with an example 2x square plus 1. Suppose we are given with a polynomial 2x square plus 1. Then what is the coefficient of x square? What is the coefficient of x square? The coefficient of x square is the constant that is with x square. What is the constant with x square here? And that is 2. So this is called coefficient of x square. Now suppose we move on to one of our algebraic expressions that we have taken. What is this? X. So what is the coefficient of x here? Nothing is there. We are not able to see anything. But there is always a coefficient for all the variables, and here you can say that coefficient of x is 1. So any variable if you take, it has a coefficient, and that coefficient is that constant value with that variable, with that degree of variable, or with you can say with a constant term also. Now if we say 5 that we have taken earlier here, this 5, we have told it is a constant polynomial. But suppose if you take 0, is it a constant? 0 is also a constant value. Can we say it as a constant value? Yes, it is a constant polynomial, but it has a special name. It is called 0 polynomial. the value doesn't change. It is always 0. It will always be 0. And special name for that constant polynomial is 0 polynomial. Now in this part, in the introduction part, we have discussed various things regarding algebraic expression. What are polynomials, algebraic expressions in terms of polynomials, types of polynomials on basis of number of terms, types of polynomials on basis of degree. We have learned regarding coefficients. We have learned regarding how to check whether a given algebraic expression is a polynomial or not. We have also learned polynomials of one variable, polynomials of more than one variable, and so on. So lots and lots of things in polynomials we will have to go through, where various things can be categorized, various algebraic expressions can be categorized, and in general, if a particular algebraic expression is a polynomial, we always give them the name. We can write that polynomial as p of x. We can also write q of x. We can also write r of x. We can assign any name to the polynomial. Suppose we want to say x plus 2. So we can write p of x. Somewhere we can write. We can write here. Suppose here we have some place. P of x is equals to x plus 2. We will have to give a special name. But in class 9, regarding polynomials, we will be very much interested in a polynomial of degree 1. Degree 1 means in class 9, we will be dealing with the properties of polynomials in linear form only. We will be dealing in our further part regarding linear polynomials only. Let us move on with example number 1 from the section 12.1. We need to find the degree of each of the polynomials that are given to us. We are given with 3 bits, 3 questions, and in each of the questions we will have to find the degree of the polynomial. What is the degree of the polynomial? We have just discussed now. The degree of the polynomial means it is the highest degree of the variable that is being used in the polynomial. If it's a polynomial of 1 degree with number of terms more than 2, more than 1, we will have to observe the variable with highest power, and that highest power will give me the highest degree. Here, bit 1, what will be the degree of the variable? The variable here is x. We can say x to the power 5, x to the power 4. So there is single variable, that is x, and the highest power is 5. Here the power is 4, here the power is 5, so the highest power is 5. So you can say degree of this polynomial is 5. Moving on to the next, same way we will check the highest degree of the variable that is used. Here the variable used is y. This is y square, y cube, and 2y to the power 8. So the highest power of y is 8. So we can say degree is 8 for this polynomial. Bit 3. 2. It's a constant polynomial and we had discussed. Is there a variable? Yes, there is a variable, and that variable is x, and the power of that x will always be 0, because we know x to the power 0 is 1. So this whole value is 1 and 2 into 1 is 2. There is no change in the value of the polynomial. But there is a variable, that is x, whose power is 0. So we can say the degree of any constant polynomial, 2, 4, 5, 1, 8, whatever it is given, the degree of a constant polynomial is always 0. So here we can say degree is 0. Clear? Now let us move on to our exercise 2.1. We will be dealing with the solution of exercise 2.1 also, as we have now changed that introduction along with the solution. So we will be dealing with exercise 2.1 also, where question number 1 goes this way. Which of the following expressions are polynomials in one variable? We have to check. What we have to check? That they are polynomials, and that too polynomials in one variable, not more than one variable. But very first thing that we have to check is whether it's a polynomial or not. If it is a polynomial, then comes the question whether it is one variable or not. So first of all, we are given with 4x square minus 3x plus 7. If you see as per the definition, any algebraic expression whose degree is a whole number. Degree is a whole number, then only it is a polynomial. Here the degree of x is 2, the degree of x is 1, the degree of x is 0. So 2, 1 and 0. The degrees are whole numbers. 0, 1, 2 are whole numbers. So it is a polynomial. Then we will be seeing whether it's in one variable or not. Yes. Here it is x square, x, only one variable is used. So this is a, yes, it is a polynomial. It is a polynomial in one variable, and the reason is the degree are whole numbers. That is, the degree of the variable is whole. Moving on to next. Y square plus root 2. Y square, one variable. We don't have any other variable here. So y square. So the variable that is used here is y square. And square, when we say the power is 2. Now 2 is a whole number. So it is an algebraic expression with degree as a whole number. So it is a polynomial. It is a polynomial. With degree 1 and in one variable. It is a polynomial, the degree is 1 and the degree is a whole number, so it is a polynomial and it is single variable, so we can say it is in one variable. Now here, and we move on to this question. If you see 3 root 2 plus t root 2, now we have to check the degree of the polynomial and not of the constant. If you see here, this was a constant. That is why we didn't check the degree. We are interested in the degree of the variable that we are using. So here the variable is t and this is 3 root t. We have gone through by the laws of exponent that root can be written as t to the power 1 by 2 plus t root 2. Now it is in one variable, that is clear, but whether it is a polynomial, the very first thing that we have to check it is a polynomial or not. For being a polynomial, for all the t's, all the variables that comes in the algebraic expression should have the power or the degree as a whole number. Here the degree is a whole number, but this half is not a whole number, it is a fraction, so we can say it is not a polynomial. It is not a polynomial. Why it is not a polynomial? Because degree cannot be fraction. Degree cannot be in fraction. The degree should always be a whole number. Now this is not a whole number, so this is not a polynomial. When it is not a polynomial, we don't have to check it into a variable or two variable. Again, let us come here. Y plus 2 by y. This is y. Plus this can be written as 2y to the power minus 1 in its standard form. If you see the degree of y here is 1, but here it is minus 1. But we have learned that for a polynomial, the degree should be a whole number and minus sign is not allowed in the degree. So it is not a polynomial because degree cannot be negative. Degree cannot be a negative number. So this is negative, a short form that we have used. Now bit 5, x to the power 10 plus y to the power 3 plus t to the power 50. There are all the degrees in whole numbers, 10, 3, 50. It is a whole number. It is a polynomial because all degrees are whole number. But what we are to ask? We are asked polynomials in one variable. Here there are 3 variables, 1, 2 and 3. X, y and t. These are the 3 variables. So we can say no, it is not a polynomial in one variable because there are 3 variables. Because there are 3 variables. What are the 3 variables? The 3 variables are x, y and t. So we can say this is a polynomial, but this is not a polynomial in one variable because there are 3 variables. Write the coefficients of x square in each of the following. There are 4 bits given in the question. 2 will be done and 2 is for your practice purpose. So we need to find the coefficient of x square. That means we need that constant value that is with x square, and that constant value is my coefficient as I have discussed. Coefficients means that constant value that is with the variable whose coefficients we need to find. Here we need to find the coefficient of x square. So we are interested in the constant term that is with x square. And what is the constant term with x square? There is no constant term seen, but there it is. I have told you, when there are no constant term, we always consider that constant term to be 1. So here you can say coefficient of x square is 1 because 1 is the constant term that is with x square. Then with 4. Root 2x minus 1, and we need to find the coefficient of x square. But there is no such x square term here. So what to do? There is. You can write this way: 0 x square. This complete value is 0. And what is the coefficient? If there is no x square term, that means coefficient of x square is considered to be 0. So here the coefficient of x square is 0. Then question number 2. Give one example of a binomial of degree 35 and a monomial of degree 100. So we have to frame 2 polynomials. One a binomial with degree 35 and a monomial with degree 100. So let us frame a binomial with degree 35. So we need a variable. Degree means it is the power of the variable. So we need a variable. You can take variable x as we have named it as p of x. The degree should be 35. Now we have got a polynomial with degree 35. But what we need? We need a binomial. Binomial means number of terms should be 2. But here the number of terms is 1. So we can introduce any term that we want. It can be a constant term or it can be a variable with degree less than 35. You can take anything. You can take x, but the degree of x, keep in mind, the highest degree is asked to us is 35. So in the second term, we cannot take the degree greater than 35. So you can take a degree less than 35, or simply you can put a constant term also. You don't have a problem, right? It has actual power 2. Then we need a monomial of degree 100. Monomial means one term with a variable of degree 100. So let us name that one as q of x. We need a monomial with degree 100. So let us take x to the power 100. Now we have that variable with degree 100 and it should be a monomial, means one term, and it is one term only. So this is a monomial with degree 100 and this is a binomial with degree 35. Moving on to the next question. Write the degree of each of the following. Let me once again revise. Degree means the highest power of the polynomial, the variable used in the polynomial, the highest power of that value of the variable that has highest degree, that highest power. If you move on here, let us write this way: 5x cubed plus 4x squared plus 7x. Here the degree of x is 3, degree of x is 2, degree of x is 1. But we are interested in the degree of the whole polynomial, that is the highest degree. So we can say here the degree is the highest degree of the variable. Here 5t minus root under 7. There is only variable here, that is t, and the power of the t is 1. So we can say degree is 1. Moving on to the next question. There are 4 bits here. 2 are done here and 2 are for your practice purpose. Then question number 5. Classify the following as linear, quadratic and cubic polynomials. There are 7 bits and we will be doing 4 for you. The rest you can do for your practice. Linear means, what do you mean by linear, quadratic and cubic? That is completely based on the degree of the polynomial. If degree is 1, then it is linear. If degree is 2, it is quadratic. If degree is 3, highest degree is 3, then we can say it is cubic. Now here, x square plus x, degree 2 and 1, and the highest degree is 2. If highest degree is 2, then this will be a quadratic polynomial. Then let us move on next. X minus x square. The degree is 2. Highest degree is 2. This is also quadratic. Then let's move. Y plus y square plus 4. The highest degree is again 2. This is also quadratic. Here. R square. The degree is 2. This is also quadratic. Similarly, if you check for degree 3, it becomes cubic, and if it is of degree 1, it is linear. That is completely based on degree. We know how to find the degree, and basing on the value of degree, we can classify them as linear, quadratic and cubic polynomials.